Welcome to the Florida Concrete and Products Association PaveWise webinar on the pavementdesigner.org website. I am Roger Schmitt. I am the Director of District and Local Road Transportation Engineering. I have been involved with concrete for over 53 years, first as an engineering technician, as a university student, and teaching assistant, and the last 45 years as a civil engineer. So welcome to our webinar, and we'll get started here. This webinar would not be possible if it were not for the Florida Concrete and Products Association producer members on the left-hand side of your screen, and our associate members, which are on the right-hand side of the screen. They are responsible for this webinar. We need to thank them. What will you get during this webinar? You're going to get a knowledge base of the pavementdesigner.org. You're going to get 1 PDH credit. You'll get a digital copy of this presentation. You'll get access to watch the video of this presentation. And here is the link for pavementdesigner.org. You need to click on that link, not now, but later on after the webinar, and sign up for the pavementdesigner.org. And I do have a very, very short take-home test for you that you can do after the webinar and send us a report. If you have a question, you can ask the question on the sidebar over there on the control panel, and we'll either answer your question during the presentation. We have Amy Weddle on manning that portion of the webinar. She's very knowledgeable in concrete pavement, and she'll be able to answer some of the questions. And then at the end of the webinar, we'll give you some time to answer some questions that she couldn't answer. And if you have any more questions after that, we'll have some time for that. Here's the course objectives and outline. How to sign up for the 3 web-based design tool. How to help find resources while using the tool. There's resources right there on the tool, right there on the web page. How to find required input values, design a concrete pavement, report a pavement concrete design, and save that concrete pavement design. And then if you need any more assistance, we'll have some other areas where you can find some more pavement design assistance. And remember that good old take-home test. This is a photo of the land Boulevard in DeLand, Illinois. It was constructed in 1939. It's 81 years old, and I live in DeLand, and I retired from the Florida Department of Transportation in 2012. The building on the left is the Florida Department of Transportation District 5 district office, and this concrete pavement is a jointed reinforced concrete pavement. And believe it or not, this was designed and constructed before the Asheville road test. And here's a photo of the Asheville road test on the right-hand side. And this test took place in the late 50s, early 60s. And basically what they did is they drove heavy trucks, for the time, heavy trucks, over 368 concrete and 468 asphalt sections. And the focus was highway pavement, so they were at relatively high speed for the time. And what they did is they kept on rolling on it until the sections failed. And you can see some of the typical sections there. They changed the thickness of the asphalt and the base materials. They also changed the thickness of the concrete pavement and the bases that they used for it. In the center, you can see what a typical section was. The typical section was 120 feet long by 24 feet in the concrete section. So they had various lengths of joints in it. And they had 6 loops. And what's really interesting, there's one loop that still exists. And here's a picture taken in 1955. And on the right-hand side is a Google Earth photo that I got off of Google Earth here a few days ago to show you that that non-destructive weather loop is still there. And what that meant was no trucks ever rode on that pavement there. And all the damage that is done to that pavement is done by the weather. The interesting thing is I don't know if that's concrete or if that's asphalt. And I'm trying to get some information from the folks up there in Illinois to find out if they can tell me if it's asphalt or concrete. PavementDesigner.org is an industry-based design. This is not a DOT design. It's not an AASHTO design. It's design that is in industry has been doing for a long time. In the 1960s, it was called the PCA method. In the 1980s, they called it an erosion model was introduced because they had a lot of faulting and a lot of erosion of the soils underneath some of the concrete pavements. In 2005, they came up with the Street Pave software, and it was released. And then in 2012, they had a major revamp of Street Pave. And in 2018, they got together and the Pavement Designer was released, and it incorporates other design methodologies. And here are some of the software that was used before, and this software is actually integrated into the PavementDesigner.org. And these are some of the folks that made this possible: the American Concrete Paving Association, the National Ready Mix Concrete Association, and the Portland Cement Association. And you can use it to design jointed plain concrete pavement, concrete overlays over asphalt, various types of cement treated bases, roller compacted concrete, and continuously reinforced concrete pavement. The Florida Green Book 2018 draft. I know there's a lot of folks from DOT there, and DOT is basically responsible for the Green Book, but what the Green Book is really used for is for city and county engineers to have a guide for how to design roadways for cities and for counties. And in the Florida Green Book, they also have a section in there on pavement design. And let me read an excerpt from that. The department's pavement design manuals, including the Flexible Pavement Design Manual, January 2018, and Rigid Pavement Design Manual, January 2018, are recommended as a guide for both flexible and rigid pavement design. Other design procedures are available, including the AASHTO Guide for Design for Pavement Structures, 1993, and procedures which have been developed by the Portland Cement Association and the American Concrete Pavement Association and the Asphalt Institute. The selection of the design procedure and the development of the design data must be managed by professional personnel competent to make these evaluations. This training is going to make you competent in making some of those evaluations, maybe not all of them, but it's going to give you some excellent training here. The Pavement Designer methodology usage. The Pavement Designer predecessor, Street Pave, was actually approved for use in Minnesota and Virginia for cities and counties. The DOTs in Minnesota and Virginia approved the cities and the counties to use Street Pave. Many other state, city, and county engineers are using it as well. Pavement design methodology also features in Dr. Norm Dillet's textbook, Concrete Pavement Design, Construction, and Performance. And I met Dr. Dillet, and he's a very knowledgeable man. Also, the ACI 325 and 330 design tables were based off the Pavement Designer's methodology. Also, it's used internationally in Australia, Portugal, Mexico, Uruguay, Argentina, Chile, and many, many more. So let's get started here with the Pavement Designer. And this is the first slide. Well, when you click on PavementDesigner.org, this will come up. This page will come up. And what you see in the middle there, it says Start Designing, or Already Registered, log in here, or Don't have an account, register here now. So I can't see any hands, but maybe some of you already have an account with PavementDesigner.org. So you basically will start designing. If you don't, go ahead, click that register button and go ahead and sign up for PavementDesigner.org. What you need is an email address and your own unique password, and nobody else can see the work you're doing on there except for you. So once you've signed up for Pavement Designer and you log into pavementdesigner.org, you're going to get this screen right here. And on this screen, you see there's some buttons on the left-hand side there. The home button, this is actually the home button right here. Every time you want to go home, you're going to see this right here. But so what I want to do here is let's go ahead and click on a new design. Let's say you're going to do a new design. So you click on a new design, and you're going to get this page here that asks you to create a new design. You enter the any design name you want to call it, your name, the route or the street, a project description, the owner agency, and a zip code. But we're going to go back to the home button because I want to go here again because I want to show you the next button down is My Designs. So every time you do a design, you'll save it and it's on that button there. So I'll go ahead and push that button there, and here's my dashboard. Here are some of the designs I've worked on, and they're all there where you can see them pretty easily. There's the names. You have project folders, and you also have design names. And what you can do is you can edit your designs. Let's say you send it off to a client and they weren't real happy with it, and they said, well, you know, I'd rather have a thicker base on there. So go ahead, you take it back, put a thicker base on it, and you do it again, you send it to them. You can also share your designs, and if at a certain time you want to delete them, go ahead and delete them. I'll go back to the home button, and they'll go down. The next one is resources. So let's click on that, and up comes this page. And this is a very interesting page. There's a lot of information that's at your fingertips right here at resources. One is a video, a Pavement Designer introduction. If you're going to share this in your office and you want people to kind of understand what it's about before they've taken it, you can show them that introduction video. The next one is the Pavement Designer map and methodology. If you really want to get into the knowledge of what Pavement Designer does and what programs it uses for what types of concrete pavement, go ahead and click on there and look at that map. The next one is, we're going to show you how to design a jointed plain concrete pavement, but there's also a tutorial there that goes through it again. So you can either watch this video again, or you can watch the tutorial, or you can maybe want to train someone in the office. You can use the tutorial here to train them. And the next one is the concrete overlay WikiPave page. There is so much information available on that page. I can't begin to tell you how good it is. But they have a number of overlay projects throughout the United States, and they even have at least one in Canada, that they are studying the concrete pavement overlays, concrete over asphalt overlays that they've done in various states, and like I said, in the United States and Canada. Very interesting information there. You can see what states they were put in, and it gives you a lot of information about it. So I'll go back to the home button, and I believe it is time. We got to go one more. There's one more button down there. See that other button on the very bottom? It says support. That is if everything here fails, but you need some more support, you got some more questions, hit that support button there. And up comes this. This is a map of the United States. And you see those, I think they're blue dots, but they're pretty small there. Maybe they're triangles. But anyway, those blue dots are where people are available to help answer any questions you have about pavementdesigner.org, or any questions you have about concrete in general, concrete pavement in general. And you can see all the cards down there. That's actually the people you can talk to. And you can see there's one blue dot there in Florida. And if you look on the left-hand side, one row to the right in the middle, Florida Concrete Products Association. We provide design assistance. So any questions you have on concrete pavement design, or concrete in general, just give us a call. Now I think we're ready to design. Now you've gone through all the buttons on the left, all this great information about Pavement Designer and other things right there at your fingertips. So let's start a design. And you get three selections here, three choices. Okay, you can do a parking lot, you can do a street, or you can do intermodal. Okay, intermodal are really the heavy duty pavements, and what we're going to do is parking. We're not going to do any parking lots today, but that is a potential future webinar. We're going to do streets today, but intermodal is another possible webinar where we'll go through all the details for parking lots and for intermodal facilities. But we're going to design a street today, a city street. You got three choices again for a city street. You can do an overlay, you can do concrete, or a new composite. A new composite might be where you do a full depth reclamation on a asphalt roadway, and you want to put concrete on top or asphalt on top. Either thing, you can design it there. But we're going to do a regular concrete pavement. So we're going to click that concrete button. Now, I wanted to make you all aware that there's several things that you have to put input for Pavement Designer, but they're not that difficult. But not all of us have that information. You may have to discuss this with other folks. For example, what is the traffic spectrum? A lot of us pavement designers may not know what that is, but you can probably ask a planner and they can tell you what the traffic spectrum type is. You as a designer, you can design, you can pick the design life. The Florida DOT right now, in the latest rigid pavement design manual, was 20 years. I have friends that work at Caltrans, and Caltrans right now is doing 60 to 100-year designs for their concrete pavements. You will need to know how many trucks per day are on your roadway. The directional distribution, in other words, if it's a north-south roadway, what percent is going north and what percent is going south? And your design lane distribution. If you have two northbound lanes and two southbound lanes, what is the traffic pattern for either lane? And you have to pick the one that gets the most truck traffic will be your design lane. Reliability is a number between 50 and 99. How good do you want your design? Do you want it 99% out of the time? It's going to last 20 years for the DOT, then that's what you pick. If you want 95, you pick 95. Percent slabs cracked at the end of the design life. I like to use 10%. Some people like 15%. Some like 5%. And that again depends on the design. It may depend on your client, or the DOT may say, no, I want 5% at the end of life. I want 10%. I want 15%. You got to figure that one out. Now the next subgrade, and when you look at the pavement structure, subgrade. And when I first came to Florida, we called everything subgrade in Illinois, but in Florida they called it embankment. They go, gee whiz, subgrade or embankment? Well, I kind of halfway figured out why they call it embankment, because almost every road in Florida is elevated over the natural ground line because things are so flat around here. So anyway, so that your subgrade there is embankment, but usually subgrade is the virgin material, but in Florida it can be embankment. But of that, you get the information more than likely from your geotechnical engineer, either in-house geotechnical engineer, or you have an outside geotechnical engineer that writes you a report. And in that report, they may give you the resilient modulus. Now, we don't use CBR here, do we? But a lot of states use the CBR. If you know what the CBR is, you can use it. Some of you folks here may know what the CBR values are of the soil. But anyway, or the R value, that's resistance value that you get from a test that you do in the field. So that information you usually get from the geotech or your geotechnical report. Concrete properties. You need to know compressive strength, modulus of elasticity, and the program actually calculates the 28-day flexural strength based on the compressive strength and modulus of elasticity. Are you going to put macro fibers in your concrete? Some folks do, some don't. But if you put macro fibers in the concrete, you get a little bit higher strength, and the concrete design will be a little bit thinner. Edge support. Do you have curb and gutter? Do you have a paved shoulder? Is it a widened lane? If you have edge support, that also gives the pavement structure more strength, and the pavement thickness will be a little bit thinner. So you got two choices there. And then the number of base or subbase layers. And let me go to the next slide here to talk a little bit about those. The number of subbase layers. In this program, you can put from 0 to 3 subbase layers, 0 to 3. Now, the design that we're going to show you that Amy did, we didn't put any subbase layers in there at all. We put 0 in there. We put it right on the subgrade, right on the embankment. And so that's how we did our design. But if you look at the DOT and how they designed it, their first layer is 4-inch thick of a hot, it's usually a hot asphalt base material, 4 inches thick. And then they also have a stabilized subgrade under that of 12 inches. But I put here 6 inches because a lot of people underneath their concrete pavements, they'll put a granular base under there. They do a lot in the northern states. So we get into Pavement Designer, and this, so the project level, if you can see, all the information is right there. You got to put the traffic in the traffic spectrum. All right. Design life, pick your design life. Trucks per day. Traffic growth rate. What is it? Usually get that from the planners too, and they'll let you know what it is. Okay, sometimes it's 1%, sometimes it's 3%. Some areas it might be 10%. The directional distribution, you know, how much the traffic is going north and how much is going south. And the design lane distribution, how many lanes are going north, how many lanes are going south, and what's the distribution of traffic. Okay, then globally, what is the reliability? What is the reliability of your design? 90%, 95%, 80%? I think with that, the DOT may have a list of what you use for each different type of concrete type of, like if it's interstate or if it's major arterial, minor arterial, they may have the reliability rates right in there. Percent of slabs cracked at the end of the life, and it will, based on all that information, it's going to give you a calculated traffic results. So the traffic data that we've selected for this design is residential. The design life is 25 years. It's a residential street. There's not too many trucks on it, 5 trucks a day. The traffic growth is 3% a year. The directional distribution is 50%. So 2.5 trucks go north, 2.5 trucks go south. And the design lane distribution is 100%. So it is 2.5 go north, 2.5 go south. Then we're going to go back to here. So we've got that information that's filled out on the left-hand side. Now we're going to have to go to the global information. There's your reliability. We selected 95%. We said at the end of the pavement life, after 25 years, 15% of the slabs are going to be cracked. And the program calculates the average trucks per day for the design lane, which is 4. And the total trucks for the design life is 33,292 trucks. Going to go back here, and the next thing you're going to click on is number 2, pavement structure. And you get 3 choices again. You get jointed plain concrete pavement, JPCP, roller compacted concrete, RCC, and you can have a continuous reinforced concrete pavement, CRCP. Normally the DOT and most folks in Florida here use the jointed plain concrete pavement design. We do have some roller compacted concrete in intermodal facilities around the state. And we do have one example of a continuously reinforced concrete pavement that the DOT constructed in a rest area on I-75. But the choice that normally used is jointed plain concrete pavement. So we're going to click on jointed plain concrete pavement. So what do we see here? We need subgrade, we need concrete, and we need structure. So let's see what it says about subgrade. Again, here I kind of repeated what I said before. The subgrade, but there's a little drop-down screen there. You click on that arrow, and you get your choice between known resilient modulus, a CBR California bearing ratio, or the R value. That's your choices. And what's interesting on the if you click on the CBR button and you need some more information, you got to go see where it says help up there. You got to go up there and click that help button, and then click on, and then these things will drop down. And what's interesting about this table is this is basically, it's describing the soil, gravel to poorly graded silt. It gives you the AASHTO classification, your geotechs like that kind of stuff. The ASTM unified classification system gives you an estimated CBR value and an estimated resilient modulus. So let's say you have an A24 material. It says that the CBR would be between 40 and 80, or 25,000 to 39,000. The DOT has a little bit less value. Their A24 for their stabilized subgrade is 16,000 PSI. We'll go that into more detail at a later date. So we'll get back out of there. And so here is the information that we had selected. A CBR of 15 that gives you a calculated resilient modulus of 12,392. We use compressive strength of 4,000, modulus of elasticity of 4 million, and it calculated the flexural strength at 580 PSI. If you look further down on that list there, microfibers in the concrete, no, we didn't use any. But we had edge support. We had either curb and gutter, or we had a bike lane that was a tied bike lane, or we had a concrete shoulder, tied concrete shoulder. And like the DOT likes to do on a lot of their interstates is to make that lane 14 foot wide. So you get, if it's a widened lane and you put the stripe at 12 feet, then you get credit for edge support with the 14 foot long lane. And on the right hand side there, you see that it lists all the granular type bases. So there are a number of sub-base layers and types. How many are there? Oh, there's plenty. But you can put from 0 to 3 in your design. You can't do more than 3. You can use a cement treated base. A lot of folks use that. Full depth reclamation. We're seeing more full depth reclamation being done in Florida here. It's a great way to reclaim your asphalt and use that in the base and improve the base and add some cement. And what the DOT likes to do too is some emulsified asphalt that they put in there too. A lean concrete base, some people use that. Hot or warm mix asphalt. The DOT uses a hot mix base. Bituminous treatment, a cement treated subgrade, lime stabilized subgrade, or a granular base. Those are your choices. So we did all that, and here's our, we click the next button, and here's our design summary. So with all that information we put in there, we see that the calculated minimum thickness is 5.06 inches. Now that's for a roadway that's going to see 32,000 trucks in 25 years. That's very reasonable for the thickness. The minimum DOT thickness, from what I've read, is 8 inches. So this would fall under a different category and probably wouldn't be done by the DOT. But this is a residential street. This is in the city. This is in a a housing project. Sure, that'd probably work. But we recommend the design thickness. We go to the next higher or next thicker 1/4 inch. So basically, it's dialed or undialed 5.2, 5.25 inch thick, and the joint spacing is 10 feet. And what Amy likes, she likes these sensitivity analysis and guidance things over here on the right-hand side. And I'm going to show you why. Load transfer. If you're going to use dowel bars, there's some recommendations here. And they're basically saying, this is the American Concrete Paving Association, National Ready Mix Concrete Association, and the Portland Cement Association, saying if your concrete is less than 8 inches thick, they do not recommend that you use dowel bars. However, since we're in Florida and you look at what the DOT says, they have a little table, and I think it's called the 350-001 series in the 4th page. Anyway, there they even discuss if you have 6-inch thick pavement that you can put a smaller size bar than 1 inch there. But then the rest is about the same as the DOT. So real interesting information there. Also, the sensitivity, Amy really likes to look, okay, we only need 5.06 inches, but we actually made it 5.25. So really, what's the design life at? And if you can see in the little box there, okay, the design life now is 40 years. So by adding, 3/8 of an inch, 3/16 of an inch, we basically got 15 more years of life out of that concrete pavement. It's very, very interesting. You'll see that other times too. Now, what you need to do is now what we want to do is we want to generate a report. So we actually hit that blue button over there that says generate a report, and up pops this screen here. You edit your design details. So you may want to change something there, or you may not. And then you want to hit the green button, which says download and view the report. And you get a report. And what's really interesting about this report, everything you put into the design is outlined in this report. Project description, there's the project description that we put in there. Design summary, recommended design thickness is 5.25. The calculated minimum thickness is 5.06, and they're both the same for doweled or undoweled. Maximum joint spacing, either doweled or undoweled, is 10 feet, and it gives you the pavement structure. So we have a jointed plain concrete surface over subgrade. There's no other subbases in there. And it gave us a composite K value of 234 PSI per inch. Now, it also, on the bottom part of the page there, it gives you the concrete information. The compressive strength being 4,000 PSI, the modulus elasticity being 4 million PSI, and the calculated flexural strength of 580 PSI. Remember, we picked edge support. Yes, we did not put macrofibers in the concrete. That's no. The subgrade, we chose a CBR of 15%, and the calculated resilient modulus of 12,392 PSI. Project level gives you the traffic information. The spectrum was residential. Design life was 25 years. Trucks per day was 5. Traffic growth, 3%. Directional distribution, north-south, 50%, 100% in the design lane. The global reliability was 95%, and 15% of the slabs will be cracked at the end of the design life. Average trucks per day over the design life, 4. Total trucks in design lane over the design life, 33,272. And here, this is the greatest thing here. It tells you which design method that the pavementdesigner.org chose to do this design. And this one was a PCA design methodology from StreetPave was used to result these results. So that's the report you get after you go through your design. And so what do? You save that to your dashboard, and it comes up, it's on your dashboard. So that's, let me go to the next slide here. Here is some other resources that are available to you from various organizations that we put them here because you can get a lot of this information from the American Concrete Paving Association. They do have a license for AASHTO, so we can use that. If we need to, we have access to it. So if you would like to use that for your design, talk to us and we can see what we can do for you with that. There's an agency practice explorer. That's real interesting. What do other states do? What do other cities do? What do other counties do? Also, if you're into airport designs, you can do an air cost life cycle cost analysis, and that information is available there. A lot of steel goes into the concrete in airfields, so they have an airfield steel calculator to help you out. AirPave, if you need design some air pavements, airport runways, an area and volume calculator. BCOA-ME, that's the bonded concrete overlay on asphalt, mechanistic empirical design calculator. There's also a bonded concrete overlay that doesn't use the ME is available. CanPave, you can get a hold of the Canadian, how they design their concrete pavement. I don't know what Compass is. Compression seal joint width calculator, if you're using compression seal. Concrete helper web apps. Sorry about that, folks. Concrete helper. There's also concrete mixture proportioner. Concrete temperature calculator. That's more like a maturity type device. And here's a good one here. Concrete pavement rehabilitation specifications for various states and for various types of the work. And a Dalbar alignment estimator. All that stuff is available. These are some other support that's available. The American Concrete Paving Association, you can call them directly. You can call them, you can send them an email. The same with the National Ready Mix Association, the Portland Cement Association. There's Wayne Adask. I know Wayne Adask is also here on this training today. And Roller Compacted Pavement Council. Good sources if you need any additional help. This is a photo of Bermuda Greens in Naples. It's one of those townhouse condominium associations, and they've decided to make all their driveways and little roadways out of concrete, and they've done an excellent job doing that, and we thank them for that. Now, what everybody's been waiting for, the take-home test. Okay, you will be designing a minor arterial street for a local city. On the following pages, you'll be given all the input information you will need for the design. First, if you haven't already done it, go ahead and establish your account at at the web page right there. When you get a copy of that, you can click right there and it'll take you right there. Design your concrete pavement. Save your concrete pavement design in your account and send me a copy of your report. And there's where you send it to. Now let's look and see what information that I'm going to give you. I'm going to give you everything: project level inputs and pavement structure. Here we go. The traffic spectrum type is minor arterial. So this is a little bit more than a residential street. I'm going to give you the design life of 50 years. There's 1,400 trucks per day. The traffic growth rate is 5%. There's 700 trucks going north, 700 trucks going south. Directional distribution is 50%. 100% of those 700 trucks are going northbound and southbound, so that the design lane distribution is 100%. We're going to use a reliability of 90, and 10% of the slabs are cracked at the end of the design line. All that information you put right into pavementdesigner.org. Now, what's our pavement structure? We have a known resilient modulus of 12,000 psi. Concrete properties: 4,000 psi is a concrete strength. The modulus elasticity is 4 million, and it's going to calculate the 28-day flexural strength. Guess what? It's going to be the same flexural strength as the example that I gave you before. There is no macro fibers and no edge support. The number of base layers is the next slide. 2 layers. So up there where it says bases, you're going to click on that button there and it'll drop down. You'll see 0, 1, or 2, or 3. You're going to put 2 in there. Layer 1, that's the layer on top, is going to be a hot or warm mix asphalt base, 1 inch thick. It's important that so you're going to put in, choose a layer. It's going to give you the PSI, but you have to put in there the layer thickness. And the second layer, which is right underneath the asphalt, layer 2, is going to be a granular base, 6 inches thick. All right, are there any questions? Do we have any questions, Amy?
I'm just unmuting myself here.
Okay.
So just a reminder to everyone that you can, on the pop-out screen on the right-hand side, there is a place you can type in questions. So, so far, more procedural questions about when will a copy of the presentation be available. I hesitate to say tomorrow because we might have to prepare for a lot of rain, but and a little wind, but it will be in the coming days. There was also someone had some challenges with resetting their password. I'm investigating that and we'll get that resolved. Are there other questions out there? So I invite people to go to the FC&PA.org website and look for future presentations. Sign up for our emails and workshops. We're looking forward to, in the future, doing presentations in person. But for now, we will continue these webinar series. So I have a question for you, Roger.
Okay.
Soil cement base being used by the DOT in Florida?
I want to say that they frown upon it. They haven't had much success with it under asphalt pavements, but we did ask them if they would look into it again, because we discussed it with the PCA Waynadaska, and they have a new method for doing the cement treated bases, and where they actually pre-roll it and basically put some micro cracking in it, so that you don't get the block cracking that could be a problem too. Another thing that they've done too is that they like to limit the amount of cement that they use, because the least amount of cement that you can use that will help you the most is the one where it won't crack. So they're right now they're also getting some designs with less cement in it, so that it doesn't shrink as much. I hope that answers the question, but we've been discussing that with the DOT.
Thank you. So I have
I think,
another question.
let me talk about something else too. Now they're doing the full depth reclamation, where they take the existing asphalt and whatever base is underneath it, and they're pulverizing it all, and they are using cement in that process. Some of the recent projects they've done, but what they also use is they use an asphalt emulsifier with it, and they've had great success and a lot. We haven't seen any base cracking yet with that product. So it's a combination of cement and bituminous materials that they're using as the cementing product, and there's less shrinkage.
And I would add just a little bit, the full depth reclamation is a very environmentally friendly process, because you're not having to haul away materials to the dump and bring in new materials. It's a cost-effective solution for a very robust base, whether you're putting asphalt or concrete on top of that. So that is something that's being used in Florida and many states, and it's growing in use as a very good solution for a base reclaiming a road and getting it ready to be reconstructed. Okay, I have another question for you, Roger. I have several questions coming in now. Okay. Is there a minimum width consideration for considering edge support?
A minimum width? I mean, are we, I guess
I think that's referring to the widened lane.
Okay, one of the things that the DOT does use is a 14-foot lane. So they added 2 feet to it, and that gives you edge support, and it allows you then to use an asphalt shoulder. What we found before on I-4, where we had concrete and we had the asphalt right next to the concrete without a widened lane, we had a lot of edge cracking. But we also had, was really strange on I-4, we actually had, I'm going to call it a tunnel under the shoulder and under the edge of the pavement for quite a distance that had washed out. So I believe in the widened lane. I also believe in concrete tied shoulders, but the DOT has decided for the edge weight. So let me answer the question and say we've also seen some lanes being 13 feet. But I think the DOT has settled on, if they're going to do a widened lane, it's 14 feet. So let's say the minimum would be 2 feet. And that's kind of the same size as some of the curb and gutters you see too, that it may be, 2-3 feet wide. So I hope that answers your question.
Follow up on that is the curb actually considered as edge support, considering the fact that the actual loading moves away from the pavement edge?
If you can consider it as edge support, if it's a tied, if you have tie bars from the curb and gutter into the concrete pavement, it has to be tied. They use a lot of tied curb and gutter in the northern states. I believe from my past experience for 1792 going through downtown DeLand that those were all tied curb and gutters to the concrete pavement. Some of the newer designs that I've seen don't do, the DOT does not actually tie the curb and gutter to the concrete pavement. So if it isn't tied, then I would say that you really can't consider that as edge support. But a lot of folks, like for parking lots and for some residential streets, their curb and gutter will be poured in conjunction with the lane. So it's an integrated curb and gutter, and that would be considered edge support then.
Very good. Another question back on the stabilized subgrade. Is chemical stabilization being used in Florida to improve the subgrade?
Actually, yes, but they don't really. I don't know if they're using chemicals, but I do know that they do a lot with cement. That they stabilize a lot of weaker soils by mixing cement in with the soil. I'm not an expert at it, but Paul Passy is there. He's probably an expert on it. I'll tell you what, I'll hold that question, and we can send that to Paul Passy and see if he can answer that for us. I'm sure, I think Paul wouldn't mind doing that for us.
So on the questions, we will also have a document to send out following the webinar. You'll get a PDF of the webinar. You'll get a link to the audio recording of the webinar, and you'll get a document with the question and answers, so we can investigate some of these and try and give a more complete answer, like for that one, for example.
And let me go to the next slide here. Oh, will it let me? Oh, I think I gotta minimize this a second. There we go. Now, what I want to say about this is how we need to stay in touch. And here's our contact information. Now, if you have any other questions that you might have about this presentation or anything else, go ahead and send it to either me or Amy, or send it to both of us, and we'll get you an answer as quickly as we can to any of your questions. And I think I have one more slide here coming soon. You want to talk about this, Amy? This is your baby.
So this will be our first annual concrete conference in joint partnership with the Florida Department of Transportation. You should be receiving in the next week an invitation. It will be an online event. That's not what we wished for, but that's the state of the current affairs. So we will be talking all about roadways, resiliency, freight, what's going on, the future of transportation in Florida, the state of the market. We are going to have one of the sessions focused on local streets and roads. And we look forward to having a big attendance, since it's not an in-person event. So I guess there's pluses and minuses to having things all going virtual these days. So this, you'll be getting more information about this in the coming week. Let's see if we have one more question.
Okay.
Does the design software take into consideration special location factors such as frost resilience?
Soft what?
Frost, and that's why I was, the software is for all of the US. So even though in Florida we don't really have to consider freeze thaw, I think the question is, does the software? And yes.
Okay, well, what happens in some of the northern states is that they have very stringent requirements for their base material. They can't have any type of base material. They can't have any type of base material that would heave in a frost situation, especially up there in Minnesota where it gets really, really cold. They have stringent requirements for their bases. So not only can you use this, but you have to really look at what the local requirements are. And so if you're going to do it for northern states, see what the requirements are, because they may not allow certain soils. Certainly, you don't want a fine silt underneath your concrete parking lot in northern Minnesota. You'll get a bunch of heave. That's why they put foundations below the frost line up there. So I hope that answers the question. Look what your local requirements are for base material.
Well, I think we have time for one last question here. Is it normal practice to validate the K value subgrade modulus reaction during construction with either LWD or FWD?
Can you repeat that?
Is it a normal practice to validate the K subgrade modulus reaction during construction with a falling weight deflectometer?
We can answer. We'll get someone that knows that answer, and we'll answer that question in our summary, because I don't know.
All right.
I don't know what the answer is.
Okay. All right. So we're coming to the end of our time. We will leave the question section open for a few more minutes. So if people have some questions, even following the webinar, feel free to type them in, and we will send those out in the follow-up email.